Hello everyone. My name is Dr. Mallikarjun B. Jalageri, and today I'm discussing about the operations research subject, which having the basic things. The topic called Introduction to Operations Research. Okay, it is a syllabus constraint for a video, so in that only we are dealing. So coming to this discussion of the operations research. Before going to this operations research, I want to give a proper meaning of this operations and research. So the name itself says that to perform any of the operations, nothing but any of the activity, so we have to do some proper research over that. So proper research over that means we have to make a proper plannings to execute that operations. That process we'll call as a operations research. To execute that, so we are using some scientific models like mathematics, statistics, and some computer applications we are using to execute the results. So that process we'll call as a operations research. Okay, so coming to this history of this operations research, how it is originated, who coined this. So we want to say that so it was discussed, it was discovered by the Britain people in the World War II. During that time they were in a scarcity of all the resources because they not had a proper planning where to use all these equipments, all the ammunitions, all the food related resources. They were scarce, they are getting a scarcity in that because they not had a proper planning when to use and how to use. They not had anything. So because of that reason they were getting the issues. So in that during that time, that commander who is leading that the defense team, so that person was thinking how I can overcome from this problem. So that time he just suggested he called all his scientists, all the all the people who are dealing with this technical things. So he called them and he asked them where we are getting a problem. So just he was asked. So then he just given some proper idea to them. So based on that, this mathematicians start working. So means they use a different methods to come with the proper outputs. So in that in that process they coined this term called operation research. And in that through that operations research they got succeeded, and once they got succeeded, the next what they done is they adopted that into the different fields. So you can see here, you can this originated during the World War II for the military logistics and strategy. So during that time it was initiated and they utilized that for the military logistics and strategy for preparations. And post-war adoption in industries, business and engineering. After completing that defense field, so once they felt they are succeeded, so they adopted that into the different fields called industries and business and other engineering fields. And you can see this I already told the scientific tools they are going to use. Scientific tools nothing but what, so you want to get an output means we are going to use some standard methods called mathematics we are going to use. So we are going to think about the statistics and we are going to think about the some computer application. So this is total, this operation research is a integration of mathematics, statistics and computer science. So then after this they've coined this, they found that this operations research, what the term is there, so that become a key decision making tool in the different sectors. So after this I already told the definitions. So you can in a textbook way you want to get the result, means you want to say the answer for this. So you can say this operations research is the application of scientific methods to aid the decision making. So you want to take any decision, so you have to make a proper strategies. That strategies are done through what? Scientific methods. So that process is called as a operation research. And it is going to utilize the mathematical models, statistical analysis and optimization techniques. It is going to, its third term is given, helps to find the best possible solutions to complex problems under the constraints. So this is the main definition of operation research. Hello, next, just on the scope of the operations research, we just have one more statement. where we can use this operations research. So what are the applications in which field we can adopt this operations research? So first point we can see here is going to concentrate on optimal decision making and resource utilizations. Again, it is going to be utilized in wherever the uh, problems need to be analyzed and need to be developed. So there we can use this operations research. The point says that it is being involved in analyzing the models, analyzing the problems, and modeling the problem, and again to get the optimal result, it is being used. After this, it is being used in different fields called logistics, manufacturing, finance, and healthcare sectors. It at the end it is going to be deals with the proper productivity and efficient and cost effectiveness process. Coming to the applications of this area OR, so we already told the scopes where it is having a scope, where we are having a decision making output we want to execute. So there this OR being used. So we have a different sectors called manufacturing, logistics, and finance, healthcare, and defense. So along with this, nowadays it is being used in our IT industries to execute the project because the project deals with the different time scales. So there it is being used because to do that, to get the output of that, so they have to plan for the proper timing. Yeah. Uh, yes. After completing this scope and next one is what applications. So we are going for the process, the how this OR is going to be processed. So the steps involved in that OR are one is the first one is not only the OR, any of the work you want to start. So there what you will do, you will search for the problem, what kind of problem it is. So the based on the level of the problem, you start preparing the models, you start preparing the work over that. Once the work is done, next what you will do is you will start implementing those things into the, your developed model. So once it is implemented, later what you will do, you will compare that with the existing model. So which if your product is giving benefits over the available material, available product, so then what you will do, you will implement that and you will impose that into the market. Once you impose that into the market, afterwards what you will do, we are going to monitor for a certain period how it is going, whether this is having any problem, any issues it is making after completing certain year, certain period. So that you are going to check, and along with this you are going to search for the feedbacks, how it is making, because based on the feedback only everything is going to be decided. So that feedback itself gives, if it is having any lacuna in that, so then what happens, that lacuna will be considered again, it will go back to the construction of the model. So then again the people who are related to that, those people will start preparing the model and start preparing the model as per the requirement. So like that the process is there. Similarly we have in OR also, the first step is what we are going to define the problem. So how you are going to define the problem depending upon the circumstances, what kind of circumstances you have. So some kind of problems here, what happens, we are going to deal with different manufacturing fields. We are going to deal with industries like software fields. So like that we have some different fields, so there we will get a different problems. So you know already in the problem, if they given any problem nothing but a project. So they will give a project for you. I need to get output of this within this period, with this cost, right? So these things are the constraints they are giving. So those things, what happens, those things are overall creating a problem to the person who is dealing there, right? So once the person get the problem, so next what he will do, he start constructing the model related to that problem. So after preparing the model, so then what he will do, he is going to input what are the requirements are there. So he is going to put the data into that, whatever the model he developed, into that he is going to input them. After inputting them, then what he will do, he is going to start solving the output. So as he get an output, then what he will do, that output he is going to compare that with the existing model. So in that, if it is giving a positive response, like positive response nothing but, if it is dominating, then what happens, he will implement that into the market, right? So once that implementation is done, so again he's going to monitor that for a certain period, and he will take a feedback over that. If the feedbacks are giving negative, like it is giving a negative feedback, so then what happens, again those feedback he will consider and he will send back that to the first statement. The statement nothing but a problem definition statement he will send back. So there again it will be recreated as per the requirement. So this is about the steps involved in OR. So coming to the characteristics of the operations research, uh, operations research, it is not only done by only one field persons. It is being done by the different team people, different team, nothing team peoples, nothing but like a different kind of stream people, like engineers and mathematicians and statisticians and some customers. These all people will come into this operations research. So this operations research is utilizing quantitative methods and computer based models. So as of now, previously what happened, they used to prepare the operations research models manually, but now we are having good information in the computer sides, means we are developing a different applications to develop the output. So we are using computer based models now. So coming to the next one is objective is optimization and efficiency improvement. So at the end output is what we have to optimize the result. We have to get the optimal solution. As we get optimal solution, obviously we'll get a good efficiency in our output. So this thing is the main concentrated property. And the next one is it's going to be focusing on real world problems by utilizing the scientific methods. Coming to the disadvantages, what are the disadvantages here? So you can see here the first one, it requires accurate and reliable data. If you not have the proper data to the system, so then what happens, it will give the result as per the given input, right? If the input is wrong, input is having approximations, so obviously answer is also going to be given as a wrong only, like an approximation only. So that will affect the output of the industry or output of the any of the project. So that's why this is one advantage. And you want to overcome from this, you should give accurate results to the system. Next one is complex models can be hard to understand and implement. If it is having more number of decision variables, we want to establish any output with a number of decisions. So I want different fields you want to execute. So very different that time. So that kind of problems will be done, or that kind of problems preparing is very difficult in OR, and may not account for the qualitative or human factors. It's obviously it's a man, the count, it is not going to be count over that. So if we can use, it may be a number of, it may be number of members used in that, it may be a quality, whatever the quality you are going, so based on it is not going to give. Because what happens is input is incomplete, obviously the quality we need to compromise with that inputs only. So if it is very clear, obviously we'll get a clear answers here. High cost and time consumptions for the large problems, and again resistant to change in the practical applications. So you know already the high cost and time consumption for the large problem means if the problem increases, obviously time is going to be consumed, obviously the cost is also going to consume as per the time. So that's why it is this, it is a one disadvantage in our operation research. Yes, coming to the next part, the models used in OR. So generally in any of the problem development in the mathematical related things, so there we are going to use these all the four or five models. So mathematical models we are going to use, and simulation models we are going to use, and deterministic models, probabilistic model, and linear versus linear, non-linear, static and dynamic models. These all models we are going to use in the operations research to get the output. It depends on the circumstances. Circumstances is nothing but limitations. How you are going to put a limitation on your problem. Based on that, we are going to use these models. So next, coming to the introduction of the linear programming. Before going to this, I want to give a brief statement on this linear programming, because linear indicates what? The equations subjected with the linear models, like ax1 plus bx2 plus cx3 plus up to cnxn. So like that, the statement whatever you prepare for this problem, it should be in a linear form. Linear programming is a mathematical method for optimal allocation of the limited resources, and it involves some certain components called objective function. Objective function deals with what, whether it is a maximization problem or whether it is a minimization problem. You want to maximize a profit or you want to minimize the loss. So that depends on that, how you are going to give a statement. Based on that, this objective function will be prepared and it is going to deal over that. So again, in this objective function, we need a main important part is decision variables. So decision variables means sometime it may be a product, sometime it may be the person, sometime it may be the machines. So these are going to make a decision in providing the output. So next one is constraints. Constraints are nothing but the limitations of what you are providing for your work. So limitations may be in a material wise, or it may be a time wise, or it may be in a amount wise, in the money wise. So you want to put so you want to develop any product, any projects, then what you will do, obviously you will put a time constraint. I want to complete this product, I want to complete this work in these many days. So this is a constraint. So then there he will give a like a quality quantity also. So by utilizing these many members only, you have to execute this product uh, within this period. So like that he will put. So these becomes what, constraint to the person who is dealing with a project. So afterwards, this linear programming is right now is being used in different fields called business and economic sectors, and again scientific engineering fields also. Coming to the problems formulations, so you can see this is a one example how the LPP formulation is done. You can see here the statement he given, maximize the profit of Z equal to 5A plus 3B. The maximize the profit. So maximize the profit, I already told, I am going to get profit. So means my aim is what, my goal is what, I have to get a profit in my work. So this is my goal. So this is going to become my objective. So this I will call as a objective function, right? So next one here we have, after this we are having a 5A plus 3B. A and B are going to become my decision variables. Decision variables means these are very important for my work. So these, by utilizing these things only, I am going to get the output for my work. So then coming to the subjected to the constraints. So here we have subjected to. So there we have a statements, two equations we have. So 100, 120 and 0 you can see here. And there we have a less than or equal to, greater than or equal to statements. So those less than or equal to, greater than or equal to, those becomes what, constraints. So you have a output here 100, 120. What are those? 100 means here he given material constraints, means I have a 100 materials only. In that 100 material utilization only, I have to complete my project. I can't utilize 101. I need to complete my work within 100 materials only. And again, I have one more constraint, the time limitation. I have to complete my work in a 120 hours. I can't utilize more than that. If I utilize more than that, obviously what happens? The cost will be more, so I'll be in a loss. So next one is non-negativity conditions. Non-negativity constraint is must and should. It should be non-negative. Whenever you are dealing with a LPP, your results should be non-negative. Non-negative nothing but it should be, it might be 0 or it may be more than 0. Is coming to this objectives. What is next topic is dealing. I just skip that part. So I will come directly to the what is linear programming. So we already have a brief information about LPP here. So coming to this proper meaning of this, we have two statements here. A mathematical technique for optimization means this is used to what, optimize the output. Optimize the output in terms of maximizing the profit or minimizing the loss. So like that we are going to plan it. This is going to be a part of that. Next one is helps in maximizing or minimizing the linear objective function. The same statement, subjected to the set of constraints. If it is having all these things, then only we'll call this as a linear program. Otherwise it is not called as a linear programming, because we have already here, you can see here what are the characteristics of LPP. So I already told previously one example I took, and that I already explained what it should contain. You want to say this as a LPP, what it should contain, I already explained. So like a decision, it should consist like decision variables and objective functions and constraints, and it should be, the equation should be linear, and it should have non-negativity functions. Then only we'll call this as a LPP. These are the basic properties of this LPP. Okay, coming to the applications, I already given the first slide was given about the LPP, so where it is used. So we are using this LPP for resource allocation and transportation and logistics, workforce scheduling, diet problems, investment plannings. So these are our applications where that this LPP being used now. Coming to the requisites of this LPP, you want to formulate any of the problem related to the linear programming. What are the requirements? The same again, the same thing is repeating here. The problem should be defined very clearly in each and every part. It should be clearly defined. So whether the problem is dealing with a maximization or minimization, means it is given here. First statement you can see here. This is about the clearly defined objective. So you have to be define your objective in a proper way. It should be systematic and it should be accurate. Then only you are going to get the output as per that. So next one is clearly define the decision variables, and next one is a constraint based resources, known coefficients. So we have a coefficients, nothing but what how many units you are using. So that is the thing. So with respect to your variables, you are using some units, that is going to be matter here. So then non-negative variables, the decision variable should be positive. So this is must and should here. And coming to the general structure, this is going to be asked in your exam for 5 or 10 marks. So 5, not 10 marks, it is around I think 4 to 5 marks maximum. It will be asked. You have to construct the general form of that one. General form of that means we already told the LPP is means the linear programming problem, means equations are set in linear way only, linearly formed. So you can see here the I already told the three components here. It should consist decision variables, it should consist objective function, and it should consist constraints, and it should consist non-constraint equations. So it should we want to formulate any of the problem, these all things should be there. So you can see here the statements they given. The status of the objective is given maximize or minimize. You want to maximize, then it will be different. You want to minimize, then it will be different. The problem may be maximization or minimization. So z, that objective will be represented by the z. Got it? So a11 x1 plus a12 x2 plus a1 n1 x1 less than equal to b1, and this b1 and b2 are going to become my constraints. Might be it is in terms of a time, or it might be in terms of the money, or it may be in terms of the raw materials, or it may be in terms of the number of people you are using. So based on that it will be. So again we have a non-negativity conditions, means whatever the decision variables you are using, it should be greater than or equal to 0. Coming to the procedure, how we are going to solve the LPP models. We have different methods here, but simple procedure they are going to give. The major concept is it connected with the steps involved in OR. You can see here, identify the decision variables, formulate the objective function, write the constraints, add the negativity conditions, choose solving methods, interpret the results. So you can say this before starting your problem, these all things should be prepared. You want to formulate any of the problem, these all statements should be ready. So then only this will be considered as a problem. Got it? As next we'll go to the next one. This is a one more example for this LPP. Status is given here. This is a maximization problem. Z equal to 3x plus 5y, and this Z indicates what? Z is an objective function. Z is indicated by this objective function is indicated by Z, and 3 is given as a unit. It's nothing but a coefficient. X is indicating the decision variable 1, and second one y indicates the decision variable 2, and it is subjected to constraints. We mentioned here subjected to constraints means, so what kind of limitations are there, what with respect to the decision variables, those all things are should be mentioned here. After that it should be mentioned with the this non-negativity conditions. Okay, so after at the end the different methods being used for to solve this LPP, we are not having only one method here, we are having different methods based on the number of variables. If I'm having two variables, then I will go for the graphical method. If I'm having more than two variables, obviously I will go for the three different methods which I mentioned here: simplex method, big M method, and two-phase method. This is brief information about our introduction part. So this will be added in your 1A is question number 1A or 2A. So these questions, it may be added in that. So please concentrate on this. Please prepare for this. Thank you.